Welcome to another video. So this is another video in which I am solving a previous year KTU problem. So this problem was asked for 6 marks in 2018 December. So this is one part of it. I think there are 3 parts in this question. This is part B of the question. It was for 6 marks. So this is from MOS semester 3 from module 5. In module 5, this is from the column portion. Okay. So in column portion, there are 1 or 2 buckling formulas that you have to remember. If you remember that, you can easily score marks from this portion. A steel column made of 4 meter long hollow circular section having 300 millimeter internal diameter and 20 mm thickness is fixed at both ends. Determine the safe axle load of the column can carry with a factor of safety 3.5 using Euler's formula. E is also given. So we can just see what all values are given. So length of the column is given. Its boundary condition is given. So 4 meter is the length and it is fixed at both ends. So this is fixed. This is also fixed. Both ends are fixed. And capital length is L is given as 4 meters. Now this is fixed. This is fixed. Okay. So the moment you get the length of the column and boundary condition, you have to write the effective length of the column. Effective length for the case in which both ends are fixed is nothing but total length by 2. So that is 4 by 2. That is 2 meters. So this is nothing but 2000 mm. Okay. So this is the effective length. Now the dimensions are given. So I'll try to get the dimensions. The internal diameter is given as 300 mm. So this I'll call as small d. Okay. And external diameter, instead of external diameter, they have given this thickness. So this thickness is 20 mm. This thickness also is 20 mm. So internal diameter plus 20 plus 20, that is 40. So 340 is the external diameter, that is capital D. Mm. So these both our dimensions are in millimeter. Remember, 20 thickness is huge thickness practically. So this is a very thick column. Normally, this kind of columns, the thickness will be 4 mm, 6 mm, 8 mm, 10 mm, 12 mm. Okay, this is 20 thick, so it's huge. Now, we have to find safe load using Euler's formula. Now, what is Euler's formula? We'll write the Euler's formula. Euler's formula is given as pi square EI upon LE square. Okay, this is the Euler's buckling formula. This is the buckling load. Okay, now E is given. What is the value of E given? I just write that also. E is given as 2.1. So 2.1 times 10 to the power 5 Newton per mm square. So 1 Newton per mm square is nothing but 1 MPa. So this is the value of E. So pi is a constant which we know. E is given here. I we can calculate since we have the dimensions. LE is given, which is 2000, which is calculated as 2000. Now we'll just quickly calculate the value of I. So I for a hollow circular section is given by pi upon 64 times capital D to the power 4 minus small d to the power 4. So in this case, this will come out to be pi upon 64 times capital D is 340 and small d is 300. So not square 4 minus 300 to the power 4. So if I quickly take out the calculator and calculate this, so this will come out to be, so let's say pi divided by 64 times 340 to the power 4 minus 300 to the power 4. Okay, so this is the value. This is 25836479. Okay, 2583. So this value 2583. So it's a huge value. Okay, so let me try to write this down. 25836 4579 4580. Okay, so 25836 4580 mm to the power 4. This is the value of I. So it's a huge value. Now we just have to substitute the values in the equation to get the value. So this is nothing but pi square times, what is the value of E? 2.1 into 10 to the power 5 times 25836 64580 divided by effective length is 2000 square. Now this is going to give very huge values. Okay, so this since I value is there in the memory, so I can use that. So let's say pi square times 2.1 times 10 to the power 5, 1 2 3 4 5 times answer. This answer will have the I value divided by 2000 square. So it's a huge value that we are getting. So 1338727. 1338727 00 Newton. So it's huge value. Okay, so this is nothing but 133,873 kilonewton. So I am divided by 1000. So this I am rounding. So 133,873 kilonewton. It's very huge value. Now safe load is Euler's load divided by factor of safety. So this is nothing but 133,873 divided by factor of safety is 3.5. So this comes out to be, so first I will divide by 1000, so that I will get the kilonewton. Then I will divide by 3.5. So this is 38249. 38249 kilonewton. So it's a huge value. So if you want to imagine this value, it is 3824 tons of load. Okay, it's huge. And as I always say, one African elephant weighs around 6 tons. Okay, so you can imagine the load it is able to carry. I feel this is too unrealistic. Right, so this is the answer to the problem. Please recheck my calculations. I am calculating live on the screen, so there could be some mistakes here. But this is how you solve the problem. I hope the idea is clear to you. We will solve another problem in the next video. Thank you.